Welcome to polar coordinates. We're going to look at the difference between rectangular and polar coordinates so that you understand what polar coordinates are. In a sense, they are the exact same as rectangular coordinates in terms of what they are. How you show them is the issue. So let's take a rectangular coordinate. Let's take a point here that we'll call X and Y. X is the amount that's here, and the Y is the amount that's here. And we think of it in terms of this being Y and moving out here is X. So it's along the X-axis and along the Y-axis, except it's actually up in space towards that point. So this point is X and Y, and that's how we number it. We number it based upon the horizontal distance of X and the vertical distance of Y. Let's take that same point here. That's a little low, so let's go about the same thing. So this is, if it was transposed on there, would be the same exact place. But a polar coordinate doesn't use X and Y to place the point. A polar coordinate uses the radius out from 0, 0, and the angle amount coming up from the X-axis. Those are the two things that we need to identify the placement of the point in polar coordinate form. We need to have the radius and the angle amount. Those are the two things. Before it was X and Y, now it's R and theta. And we will use them interchangeably. Well, not quite. You will learn how to transfer from one to the other. And there's a few other things we'll do. One of the things is to identify the radius times sine theta and the radius times cosine theta. Okay, the reason for that is because the radius times sine theta is equal to y, and the radius times cosine theta is equal to x. Let me explain what I mean and show you how we derive that. So I'm going to take a nice big graph here. Sorry, the lines are not completely straight, but it'll give the right idea here. And I'm going to take a point here, just like I did before, with the radius here and the angle here. We also know that this point is y, this amount is y, and the amount down here is x. Well, we know our sine, cosine, tangent. We know so, ka, and we're not going to use toa at this point, but we're going to use so and ka. But we're going to use that the sine, come down here for it, the sine of theta is equal to the opposite amount divided by the hypotenuse. And I am now going to take that and I'm going to multiply it around. If I multiply by r, I get r sine theta is equal to y, or usually we put the y on the other side. We just switch them. So these are the same. Oh, that means up here, I can say that y is equal to r sine theta. Okay, so this is a really important thing, so that this distance that's here, if we want to know that distance and we know the radius and theta, then we can do radius times the sine of theta and we get that distance, or we get the y value of the point. And we can do the same thing with x. The cosine of theta is the adjacent, which is x, over the radius. Multiplied by r, we have r cosine theta is equal to x. I like to have the x over on the left side, so we'll just use the equal sign and switch the things, as long as it's everything. And that means that x is equal to r, oops, I've got to put the r there, r cosine theta. Those little formulas right there are going to help us as we do some other things in the coming parts. In fact, I want to make like a box around them because we're going to use them again. They're going to be very important to us. All right, let's go on to the next part where we're going to graph some polar coordinates. Well, what we're going to do is we're going to graph a rectangular coordinate, and then we're going to find the polar coordinate. So I'm going to take first the rectangular coordinate, rectangular coordinate of 4 and 8. So if I go out 4, 1, 2, 3, 4, and up 8, I'm at this point right here. 4 and 8, that's right here. And we're also at 0, 0. So that's the rectangular coordinate, but to get the polar coordinate, okay, and now I'll write polar coordinate, that's going to be the radius and theta. Well, here I can do this. Okay. And we have two ways of getting the radius. This is the radius here. Oh, and of course, then this will be the angle going up from the x-axis. We need those two things. So first, to get r, to get the radius, I'm going to write that a little neater there. To get the radius. Well, you can use the distance formula of 4 and 8 with 0 and 0. It's the same thing actually as using a squared plus b squared equals c squared. Although in this case, what it is x squared plus y squared is equal to r squared. So if it's going from 0, 0, then we have an x here of 4 and an y here of 8. So we have 4 squared plus 8 squared is equal to r squared. And so we can use the 4 and the 8 from the rectangular coordinate. Okay, that's 16 plus 64 is r squared. That's 70, 80, 80 square is equal to r squared. So when you take the square root of it, r is approximately equal to 8.94, which that rounds close enough to 9 to be able to say 9 units. Okay. 9 units. So we now know that the radius is r. So I have so far a 9. And now I need to find the angle. So let's do that on the other side of the space here. To get theta, okay, well, we can use x or y because now we happen to know two things. We can either say x equals r cosine theta, or we can say y equals r sine theta. I'm going to go with the x. X equals r cosine theta. I know that the x is 4. I know that the radius is 9. So it's going to be approximate, but it'll be close for this because we were so close rounding up to 9. Otherwise, I'd put 8.94 or 8.9. 9 times the cosine of theta. I don't even need to put that part in parentheses. Oh, I keep trying to do it, but there. 9 times the cosine theta, divide 9 by 9, 4 over 9 equals the cosine of theta. If you want the angle for cosine, you do cosine minus 1 of the amount of the cosine, and that will give you the angle. And then put that into the calculator, and you get approximately 63.6, which we can round to 64 degrees, or leave 63.6. I'm going to make it 64 degrees. And that is the polar coordinate. So to get it, we use the x and the y, and then either the x or the y first to get the radius, then to get the angle. Let's do another one now where there are some negatives, and this next one has a twist to it. Okay, and I will show you the twists, and then we can compare them. So let's say that the rectangular coordinate is -9 and -5. So I'm going to go place that first. -9 and -5 is here. I'm going to draw this just because it makes it easier for me to see. Okay. So this point's -9, -5, but what I want is I want the R and I want the angle. So in order to do those, to get R, I need to do x squared plus y squared equals r squared. And I already know x and y. -9 squared plus -5 squared equals r squared. The negatives will cancel. I have an 81 plus a 25 equals r squared. So r squared equals to these two added together, which is 106. Take the square root of it, and r is approximately equal to plus or minus 10.3. Now, we can't have a negative because distances are always positive. So I now know that r is 10.3. And now I need to know the angle. Okay. To get theta, I can use either x or y. Last time I used x, this time I'll use y. Y equals the sine of theta. Oops, I forgot to put the r in front. R times the sine of theta. Now we know two things. We know the -5, and we know that the radius is a 10.3. Okay, times the sine of theta. When I divide by 10.3 equals sine of theta, I'm now going to do sine -1 of -5 over 10.3. And when I do that, I get approximately -29 degrees. Now, there are some of them, some calculators will actually show it as -151. Whatever you get, what we're going to do is we're going to look at this and determine from this what we should have, because -29 is definitely not this, unless you look at going from the x-axis to it as a reference angle. Even then, we would normally say +29. But what we do now is we use that to identify that this distance is 29 degrees, okay, and the negatives in are superfluous for this because we know that in this quadrant, we know that the x's are negative and the y's are negative and the tangent's positive. But we know that the sine will be negative, so the negative makes sense. We can actually use negative or the 29 degrees here or as -29, which is not a good answer because you could also pretend to get -29 in two other places. Not in this one, of course, because it's first quadrant, but you can get -29 the other way if you think about, how you want to use a perspective for it. Well, none of those perspectives are going to work. You need to use this one where you can either use all the way around to it. So it's 180 plus the 29, which gives you a 209 degrees. Let's get that 9 in. Or you can use the negative coming to it from this way, which would be -151 degrees. -151 degrees. Okay. So either one of those would work. Both of them could make sense. I would suggest that the better one to use is to come this way because it comes from the main terminal side there, or initial side, I should say. That's the initial side. I can't write that clearly enough unless I enlarge it. The initial side. So using the initial side, I'm going to say 10.3 and 209 degrees. This would also be acceptable as 10.3 or 10. You could round it down to 10 and -151 degrees. But the better answer is to use this one coming all the way from the initial side as normal. Okay. So either of those would identify this place, but don't use the -29. So sometimes if you get something, you need to determine where it is and where it should be from. On the first one, that didn't matter because here we were coming up from the initial side already to get the 64 degrees. So there wasn't any choice on that one. We wouldn't need to go backwards around there. So although that would be a correct answer, it wouldn't be a normal answer. Okay. Now let's look at polar graphing on the polar graph itself. And this one has the circles in it. So first thing is we're going to number the circles, 1 unit per each. Sometimes we're going to number these as 0.5s, but I want us to go out all the way to 10. So if we did it by 0.5s, then every 2 of them would be 1 integer and we'd go out to 5. And there are times you'll get that too. So what I want to do is to identify where 3 things are here using R and theta. So A, and then B, and then C. So for A, let's find 5 and pi over 3. In this case, you start with the angle first. Okay, so start here. Start with theta. So you go and identify where that is. Well, if this is pi over 2, then here is pi over 6, and here is pi over 3. And this is pi, and 3 pi over 2. And that'll help to orient us so that we can work with it going around for the next ones too. So you go towards pi over 3, and you go the distance of 5. So first you have to identify that you're going towards pi over 3, and then you identify the distance here, which in this case is 5. Okay. So that would be A, which is pi over 3. So A, 5, and 5, and pi over 3. So next, I think I'm going to yellow that in there. Now let's look at B. And B, I'll put in red here. We're going to do 9 and pi. So go to where pi is. So we're going this way. And we're going out a distance of 9, which is here. So 9 and pi. And for the third one, we're going to go 6 and 4 pi over 3. So find 4 pi over 3. Well, if that's 1 pi over 3, here is 2 pi over 3. This was 3 pi over 3, so 4 pi over 3 is down here. So we're going this distance, but we're going out 6. 1, 2, 3, 4, 5, 6. So we're going there. So I guess I could say I'm going up that way, that one. And so that one is 6 and 4 pi over 3. So start with the angle, move that direction, the distance for the radius. That gives us 3 examples, but none of these have negatives in them. The next one we're going to do has some negatives. So this is R theta, and now it's with negatives. Okay, so I'm going to call these D and E and F. And so for D, let's find -4 and pi over 2. So once again, 0 and 2 pi here. 0 and 2 pi. Over here is pi. Here is pi over 2. 3 pi over 2 and pi over 6, pi over 3, and we'll add others as we need them. Well, pi over 2 is this direction, but the negative tells us to go the other direction. 1, 2, 3, 4. And so that means we are actually going here so that D, which is -4 and pi over 2. Okay. So that is our first answer. And that's what the negative means. For the negative for the radius means go the other direction. Well, for the angle, it means something sort of similar, but not the same. Let's do 6 and -7 pi over 6. For an angle, the negative means go the other direction around the circle. So we're going to go that way, and we're going to go, let's see if this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, is that right? 3 pi over 6, negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 to negative 7 pi over 6 here. The negative should go in front of the whole thing. So that's the direction we're going, and we're going 6 spots. 1, 2, 3, 4, 5, and 6. So this one here is letter E, and actually I want to write it. This is letter E, and it's negative 7. Oh, need to put the 6 first. 6 and negative 7 pi over 6. Oh. Okay, I think I got enough filled in here. All right, now let's do F, which is going to be negative 6, so that will go the other direction, and it'll be this negative pi over 6. So notice in D, I made the radius negative. In E, I made the angle negative. In F, I'm making both the angle and the radius negative. So we need to find where negative pi over 6 is, which is actually the first one here after we go the other direction from 0 and 2 pi. And we would normally come here towards that, but instead we're going to go the other way, O, which lands us back at the same exact place as E. It's negative pi over 6, so we went to here. We would normally go towards it, but the negative on the 6 means go the other way. So we are now going up towards there, and we go 6 places. And so it turns out that this actually doubles as the E and the F point. So it is E at 6 and negative 7 pi over 6. It's F at negative 6 and negative pi over 6. So the same point has two specific meanings, or two specific addresses to it. As in the same way, let's see, this one here, I could have written that one as 4 and 3 pi over 2. And that would have been the exact same thing. So those are two addresses for the same thing. E and F are two addresses for the same thing. All right, now let's take a look at what we call multiple representations. And what that is where we are going to add we're going to add 2 pi n to go around the circle an extra time. And we'll do that here. And you've done that sort of before. It's not really an unusual thing for you to find a coterminal point. You just haven't done it with polar coordinates. So let's make some polar coordinates with it, right? So I'm going to use the specific polar coordinate of 7 and pi over 2. So pi over 2 is here. 1, 2, 3, 4, 5, 6, 7. So I'm going to keep the normal numbering. So that's 7 and pi over 2. Well, for an angle, if I had it as 90 degrees and I added 360, I would get 450 degrees, and those would be coterminal. And if I did 90 degrees plus 720, I would get, what's that, 790? Oh, no, not plus. Yeah, because 360 twice is 720. So I'm now going around the second time. It would be like adding 360 to the 450. And that would come to 810 degrees. So that's another one. 90 and 450 and 810 are all coterminal. They're all the same angles. I could write that as 90 degrees plus 360 times the number of times I want to go around. And that would cover all the possible ways around it, every single one of them, and many times around. It would even be dealing with it as a negative. Okay, so So let's see, what am I thinking on here? Oh, yes. I would also be dealing with it as if I did that as -1, I'd be going the other way and I'd be subtracting 360. I get to, let's see, what would that be? Subtracting 360 would be 270. So it'd be -270. So 90 degrees plus 360 times -1. 90 minus 360 is 270, and it would be a -270 degrees, and that would be the same place. However, we're doing this with pi. If we're doing it with pi over 2, we have to add 2 pi to get the same representation, which is pi over 2 plus 4 pi over 2, because you have to have the same denominator, which means that has to become a 4 on top, which makes it 5 pi over 2. So pi over 2 and 5 pi over 2 are the same. If I add another 2 pi or 4 pi over 2, I get 9 pi over 2. And then I could add 4 more and get 13 pi over 2. And I could keep doing this all day, but I don't need to write them down all. What I need to do is do pi over 2 plus 2 pi times n, or the number of times I'd be going around. And if that was negative n, -1 time, I would be, or 2 times, I would just go backwards. And in this case, I'd get, -3 pi over 2, and that would be the same. So multiple representations for polar coordinates, in this case then, would give me 7 and 2 pi, oh no, and the normal pi over 2, then plus 2 pi n, and that's what I would actually put as my answer. I would still have radius and angle, but the angle now is written with that little bit extra there, which means that it's numerous representations of it. Now, we can also deal with just simply a negative, a simple one-time thing, where this one you've already seen, so I won't harp on it here. This is 7 and pi over 2. And you know that you can also get the same answer by going this way, or going to -3 or +3 pi over 2, but then going the other way. So what we would do is do -7 and 3 pi over 2. And those are equal. Okay. Let's get back here. Is same as this. Okay. So this is a multiple representation, and this one is also. And this one, if we want to do it more than one time, which actually I like that idea, so I want to show it, we would say 3 pi over 2 plus as many times around as you want. So actually, that would be a better answer because it would encompass all of the possibilities that you could get. And let's get this yellowed in. Ooh, it's somewhat cooperating. Yay. Okay. Now let's take a look at converting from rectangular coordinates to polar coordinates. We've already gone from polar coordinates. Let's see. We've gone from rectangular to polar. I know what I want to do this. I want to do it with a different thing than what we did. I'll show you. First thing, we need the r, and then we need the theta, but not using r sine theta or r cosine theta. We're going to do a different one this way, a different time, different way. Let me write that better. Not using r sine theta or r cosine theta. So we're not going to use those. We're going to do tangent actually in a moment. And I'll show you. We're going to do that the tangent of angle is equal to y over x, and we'll look at that. And so right now, first to get the r, x squared plus y squared equals r squared. -1 squared plus -√3 squared equals r squared. That's 1 plus 4, or 1 plus 3 rather. So we have 4 equals r squared. So r is equal to plus or minus 2, except that we know it has to be positive. So we now know that we have a 2 here. Okay, so we have 2. Now we need to find the angle. And here's the thing. We know already that y, use the red for it, here's y, and here's x. So we know that the tangent of theta is equal to negative root 3 over negative 1. And that means simply that that's root 3, because the negatives cancel, and it's over 1. So when we have the tangent of theta is equal to root 3, we want to know what the amount is for theta. So it's tangent minus 1 on the calculator to get the angle when the tangent is root 3. And it comes to, that's theta, we get that theta is equal to 60 degrees. And let's think about where this is placed though. Okay, so now we have to think about the circle. Normally this would be 60 degrees here, but negative 1 and negative root 3, negative 1 would go about here and negative root 3 is less than 1. So it's somewhere down around here. Okay, root 3, something like this direction around here. And so wherever it is, what we're doing is we're looking for the 60 degrees where it's here. So we have to do this entire amount. Do it with the red. We have to do from the initial all the way around to it. That's the one we want, which is 240 degrees. So the 260 becomes 240 by adding 180 to it. And so we have 2 and 240 degrees. There. Okay, so let's look at what we did. I set up here is the first step was to find r. The second step was to use tangent by using y and x, sort of like, or I'll call that 2a. Okay. And then once you got the 60 degrees, we did this part, noticing we're in the third quadrant. So we have to use the reference angle plus 180, and that would be like 2b. So it's like 3 steps to it. Yeah, I guess actually, I think I'll call it 3 and 4. So knowing the formula here, knowing this formula, then being able to do that would be the third thing, and then being able to do this would be the fourth thing. Take a moment and do it with the one that's on the bottom here. You have this example to follow, and do it here now yourself with this problem. Pause the video and come back when you're done, and I'll start in about 3 seconds my time, but you'll have had time to work on it. Okay, welcome back. Let's find r. So it's x squared plus y squared equals r squared. 2 plus negative 2 squared, plus negative 2 root 2 squared equals r squared. So that's 4. And the 2 squared will be 4 times 2 is 8. So we get an 8 here. And that's because negative 2 root 2 times negative 2 root 2. Negative and negative cancels out. 2 times 2 is 4. Square root of 2 times square root of 2 is simply a 2. R squared equals 12. So R equals square root of 12, which is approximately, actually we have to do 2 things here. If we first realize that there's a 4 in here, we can make that 2 root 3, and then approximate this as 3.5 units. So this square root of 12 is not an acceptable answer. That is an acceptable answer, or that is an acceptable answer as an approximation. Okay, this one is better because it helps you more closely identify the place where it is. When you say 2 times square root of 3, people don't know what that number actually is close to. When you say about 3.5, then that makes a lot more sense to people. All right, now let's find theta. And we're going to do it with this method using tangent of theta is equal to y over x. Well, y is negative 2 root 2, and x is 2. those will cancel out. So the tangent of theta is negative root 2. Tangent minus 1 of negative root 2 will give me the angle. And when I put in that in the calculator, I get that it's approximately negative 55 degrees. All right, let's figure out what that means. So we know because of the cosine sine, okay, y is negative and x is positive. The place where that's true is in this third quadrant down here. So that means we do negative 55 here, negative 55 degrees, but we want the all the way around here. So we do 360 minus 55 to get 305 degrees. And that's the thing that we want. Put the degree sign and use that number. So back up here, what we want is a radius of about 3.5 and an angle of 305 degrees. And that is the best answer for this. There, cool. Okay. Now, one last thing to look at. Ooh, not quite. There's actually a couple of things here. We're going to convert polar coordinates to rectangular coordinates. We've done the rectangular to polar coordinates using two different methods for the angles. Now we're going to go from polar coordinates to rectangular, and some of this is easy. For the x, we know that x is equal to r cosine theta, and for the y, y is equal to r sine of theta. So x is equal to 4 cosine of pi over 3. Y is equal to 4 sine of pi over 3. X is equal to 4. Well, the cosine of pi over 3 is 1/2. So x is equal to 2. Y is equal to 4. Sine of pi over 3 is square root of 3 over 2. So y is 2 root 3. 2 goes into 4 twice. So we would use those two and write our answer as 2 and 2 root 3. Okay. 2 and 2 root 3, and that's the rectangular coordinate. You could round the 2 root 3, which I hadn't written down, so sorry. So you could round that if you wanted to, but it would be better in some cases to leave it as the exact answer. It depends what you're doing with it. If you're told to leave it as an exact answer, then leave it with the square root. But if it doesn't say, then it's your choice. So this is a good answer here. This one's done the exact same way. Use r cosine theta and r sine theta. Go ahead and do this yourself. Pause the video and come back to it when you're done, and I will start doing it. Welcome back. And so x equals r cosine theta. X equals 5 cosine 3 pi over 2. X equals 5 times, well, the cosine 3 pi over 2 is 0. So x is equal to 0. Y is equal to r sine theta. Y is equal to r sine at 3 pi over 2. Y is equal to 5. I should have put 5 in here. In fact, I'll do it now. And the sine at 3 pi over 2 is negative 1. So y is negative 5. So our answer here is 0 and negative 5. And that's the same as 5 and 3 pi over 2. Okay, if you got that, you're in very good shape with it. If not, look at what I did on the differences for these. All right, now let's take a look at converting equations from polar form, equations now from polar form to rectangular form. Some of this is surprisingly easy, partly because it's just hard to recognize something. Once you recognize it, it's easy. Well, we're going to use, for instance, in this case, this formula, because it's got that R in it. There's not enough info in the others. Looks like there's not enough here either, but not until you put something into it. So first, let's put the 5 into that r. And so I get 5 squared equals y squared plus x squared. Well, things are out of order, but that actually should make some sense if I switch things and put the x squared first. Oh, doesn't that look very familiar? That is the same as x minus h squared plus y plus, oh, not plus, minus, y minus k squared equals radius squared. The h and the k are the center of a circle, and the r is the radius of the circle. So in this case, we have x minus 0 squared plus y minus 0 squared is equal to 5 squared. So 0, 0 is our center, and 5 is the radius. We wouldn't write 5 squared, and we don't need to write the zeros. What we have here is a circle. If the radius is 5 and no other info, that means that you're going in a circle around the center. So r equals 7 would be a radius of 7, or x squared plus y squared equals 49. For this next one, please make a change. Let's make that 2 pi and 3. That was a typo. It was supposed to be 2 pi over 3, not 3 pi over 2. And then let's go and do it with that. We're going to use this one here, tangent of theta is y over 6. So I am going to rewrite this much more neatly like this, and I'll just cross out this part. So what I'm going to do here is say that the tangent of 2 pi over 3 is what we want to find. If theta is that, let's find the tangent of theta. And if we do that, we realize that it's actually, let's see, 2 pi over 3 on the unit circle should give us negative root 3. Okay, let's see, 2 pi over 3, yep. And we make that like this. So this gives us a y and x. Actually, we need to determine where the negative is here. So if we do the unit circle, pi over 3 is here, 2 pi over 3 is here, and in that particular case, the cosine is negative and the sine is positive. So that's square root of 3 over negative 1. So we know it's a negative root 3, and that's because it's a negative 1 on the bottom. Okay. So with the y, what we now do, we know that that's y and that that's x. Okay. So let's set that up as y over x equals square root of 3 over negative 1. Multiply both sides by x. Now we don't need that negative 1 there anymore. We'll just put it negative root 3x. You now have an equation. That equation, if you were to put it in x and y table or graph it with this as the slope, will give you this line that goes out to pi over 3. And so saying that the angle is pi over 3 is like having a radius there, but it doesn't give you a radius amount. It just tells you where it's going. It's telling you it's this angle, and that means it goes out forever there. It's from 0, 0 up to there. And this is the equation of that line that goes out from 0, 0 in that direction. Okay, the last thing to look at here, r equals 4 secant theta. Secant is 1 over cosine, so let's change it. R is equal to 4 over cosine theta. Multiply both sides by r by cosine theta. I get r cosine theta is equal to 4. I think I remember something about x being equal to r cosine theta. Yes, of course. X and r cosine theta are the same, so let's rewrite that with x as x equals 4. Oh, that's our angle, or that's our line rather. We've just changed this equation into that equation, x equals 4, and that's all we need to do. Okay, that's simple. A couple of these are really pretty simple. The first one and third one are. The other one takes some more thinking. Well, they all take some thinking, because you have to realize that this one is simply a circle, and that this one is simply x. X equals 4 as a vertical line. And this one is a diagonal line, because it's y equals mx plus b format, and the b, of course, is 0, because it's going from the origin. Well, there were a lot of things in this one dealing with polar coordinates. I hope that it made sense and that it helped to see all of these examples. So thank you for watching and listening.